Hello friends. In last lecture we discussed about the distinguish between the classical and quantum statistics, and we know that in classical statistics the Maxwell statistics is there. In classical statistics we discuss on the MB statistics, means what? Maxwell Boltzmann statistics. And in quantum statistics there are two types. One is the Bose-Einstein statistics and another is the Fermi-Dirac statistics. Okay. In present lecture we discuss on the derivation. What is the distribution law, that is called as Maxwell-Boltzmann distribution law? We want to discuss on that, or we want to find out what is the expression for the Maxwell-Boltzmann statistics. And for this we already know that what is the difference between the Maxwell-Boltzmann statistics and what is the difference between the Bose-Einstein and Fermi-Dirac statistics. And now we want to go to the expression like this one. We want to find out the distribution law for the Maxwell-Boltzmann distribution law. So I am going to use the smart board for that, and we are taking the derivation with the help of derivation like this. See, like this derivation we want to discuss like this. We want to find out the probability of the distribution of the particle in most probable distribution, and we want to go to this expression. Before that we want to study the probability of the particles. We want to go to the probability of arrangement of the particle, n particle in K cell. Okay, so we go to this with the help of this. For that we want to use this see, in Maxwell-Boltzmann distribution law we want to study the before that one expression, that is for the arrangement of the n particle, probability of arrangement of n particles in K cell, in K cells. Okay, so this is one of the important derivation before the Maxwell-Boltzmann statistics. In unit number 4 we want to discuss the how this number of particles can be arranged in K cells. For that we are considering a box of area which is divided into different compartment, or you can say that a small area. Okay, we are considering the each area of value a1, a2, a3 like this, and at last ak. Okay, this what is this? a1, a2, a3, a4, a5, ak. a1, a2, a3 is nothing but the area of the cell. We divide this area into small cells, and we divide this area into K cells. And if we are considering the summation of this area, we can write this as the total area of the box. Means we divide the area A into small box like A1, A2, like this one. Okay, this is nothing but the summation of AI is A. Now, while we are considering the arrangement of the n particles in K cell, then it required some probability distribution. Generally, what happens, the arrangement of the number of particles in this cell, it may be depends on the area of the cell. It may be depends on the area of cell. Like when the box has the more area, more particle will be occupied by that cell. If the area is small, then less particles occupy the cell. Means it depends on the property of the cell. Means the probability which depends on the property of the cell is known as the priori probability. Priori probability. This is a very important definition. One of the important definition. What is that? Priori probability. Okay. What is priori probability? The probability of the arrangement of the particle in the cell, it depends on the property of the cell, like example area. Okay, and if we are representing that prior probability as a GI, if we are considering that, and it depends on the area, we can write it as AI. If the ith cell we are considering, if we are suppose that ith cell we are considering, and we are considering that the probability of the ith cell is gi, that is prior probability which depends on the area of that cell, then gi is direct proportional to ai. Gi is the prior probability which depends on the area of ai, then we represent as a gi direct proportional to ai, then gi is equal to ai. We are writing here gi is equal to direct proportional to ai. When we are considering the proportionality constant k, then we can write it as a gi is equal to ki, kai. We are considering the summation on both sides. What happened? Summation of both sides is equal to summation of k ai, and when we are considering this k constant, summation of ai. But what is the summation of ai? Ai is nothing but the area of the box, total area of the box, then we can write it as the ka. But in the left side we are considering that gi is nothing but the prior probability, and we know that total probability of the system, any system we can consider as the 1. Total probability of the any event is 1, and therefore we can write it as a ka. This is the 1 and this is the ka. Then what happened? What is the value of k? K is nothing but the 1 by a. K is nothing but the 1 by a. Then we are considering this, we can get gi is equal to ki. Gi is equal to kai. Then we are substituting the value of k as 1 by a ai. This is nothing but the gi. What we get? Gi is nothing but, it is very important relation we required in further, 1 by a ai. See, in this article we are considering about the probability of n particle in k cell. We are considering the n particle in k cell, and we want to show that the prior probability is directly proportional or depends on the property of the cell, that is the area of the cell. Okay, on the basis of that we are considering gi is equal to 1 by a ai. Okay, now if there are the one particle, and if gi be the prior probability, then for one particle we are considering the prior probability is gi. If there are the two particles and gi be the prior probability of both particles, then we are considering it as a gi into gi, nothing but the gi square. If they are the ni particle for the ith cell having this prior probability gi, then we consider that probability is nothing but the gi into as like n items, and then we can write it as a gi raised to ni. If we are considering for the ith cell and there are the number of cells are there, then total probability we can write it as a g1 raised to n1, g2 raised to n2, g3 raised to n3, and gk raised to nk. Okay, just like this prior probability, this is the total prior probability. Total priori probability. Remember that. Now we are considering the thermal probability. Thermal probability, and we are representing that by the help of the formula as m. And what is that? It is nothing but the arrangement of the n particle in k cell with the different ways. Okay, when we are considering the n particle arranged in k cell but without changing the numbers, we can write this as a ni factorial divided by n1 factorial, n2 factorial, n3 factorial, and nk factorial. Okay, this is the factorial. Remember that this is a symbol of factorial, which is nothing but the, just like a like if we are considering the n factorial, we can consider 1, 2, 3 multiple with the n number. Okay, we are representing that n factorial. We have got the total probability. Now total probability is given by omega. You can consider that the omega is nothing but the m into g, where m is nothing but the n factorial divided by n1 factorial, n2 factorial, n3 factorial, nk factorial, And what is G? G is nothing but the G1 raised to N1, G2 raised to N2, Gk raised to Nk. Therefore, we are considering that omega is nothing but the N factorial divided by product of the Ni factorial into Gi raised to Ni, product of I is equal to 1 to N. Now, we are taking the ln of omega. We can consider this as a ln of N factorial divided by summation of ln of Ni factorial minus, when we are considering this is nothing but omega is equal to N factorial divided by N1 factorial, N2 factorial, Nk factorial, G1 raised to N1, G2 raised to N2, Gk raised to Nk. In simplify, we can write it as a ln of N factorial divided by, or you can write here just minus, when we are applying the logarithm on both sides, ln of omega is equal to nothing but minus Ni summation of ln of Gi minus summation of ln of Ni factorial. Here we are applying the Stirling approximation, and on simplification we can get ln of omega is nothing but, on simplification I am going to simplify it directly, that we can get the term as a n ln n minus n plus ni summation of ln gi minus summation of ni ln ni plus summation of ni. This term get cancelled, and on simplification and taking the most probable distribution, by most probable distribution, what is the most probable distribution? Generally, for any function maxima and minima, we are considering that the given function has the first derivative 0, means we are considering that this delta ln of rho is equal to 0. Okay, then we want to apply the same for the right side, means we want to take the differentiation on right side also. So with the help of that, how we can write 0 is equal to, there was the remaining terms what, n ln n minus ni summation of ln ni, sorry it is plus, minus summation of ni ln of ni. Okay, now we are taking the differentiation on both sides, therefore this is differentiation term, this is differentiation term, and this is differentiation term. Okay, this is gi. Then what happened? This n is constant, therefore delta n is equal to 0. Okay, so we want to take the integration derivative of this, therefore 0 is equal to 0 plus summation of ln gi delta ni minus, this term can be expanded in such a way that we can get only minus summation of ln ni delta ni. And the another term was there, when we are considering that the ni is constant, derivative of this leads to the function to be 0, and therefore we are get this minus ln ni delta ni. Now on simplification what we get? Summation of ln gi by ni delta ni is equal to 0. This is one of the term. Now to simplify this equation, we use the another terminology, that is what? Why this is delta n is 0? Similarly, we can say that delta ni also 0. Okay. Now, when we are considering that summation of delta n is 0. Okay. Now, when we are considering the summation of delta n equal to 0, this is another simultaneous equation, and to solve this, we want to use the Lagrangian undetermined multiplier method. What? We want to use the Lagrangian undetermined multiplier method, and for that what? We want to multiply with alpha and add with this. Okay. Then what we can get? We can get summation of ln gi by ni plus alpha delta ni is equal to 0. So summation of delta ni is not 0, but this is 0. Therefore, ln of gi by ni plus alpha is equal to 0. Then ln of gi by ni is equal to minus alpha, taking exponential on both sides. Therefore, we can write gi by ni is equal to e raised to minus alpha, and we can write gi is equal to ni e raised to minus alpha, or you can say that you can represent like ni is equal to gi e raised to alpha. See, here is the important term is that when we are taking the summation on both sides, what we get? N is equal to e raised to alpha. We get n is equal to e raised to alpha. We resubstitute here. What we get? ni is equal to gi into e raised to alpha is nothing but the n. Okay, this is the important term. And what we get earlier, in earlier step, here what we get? Ni is equal to gi into n, and in earlier stage, what we get? Gi is equal to 1 by a ni, and we have given what we get? Ni is equal to gi into n. Then when we are substituting this value here like this, if you want to resubstitute here, gi is equal to ni by n. We are resubstituting here. What we get? Gi is equal to we are substituting here, and what we get? We can write here gi is equal to ni by n is equal to 1 by ai. Then to arrange this, how we can arrange this? We are considering that ni is equal to n by ai, and this is nothing but the constant, and this represents that ni directly proportional to ai, and this shows that the number of particles arranged in a cell depends on the area of the cell, and this is the end of the conclusion. Okay, this is the end of this first derivation. Thank you.